All right.
Michael, if you can share the screen now, it's been broadcasted.
Okay. Will do.
Thank you everyone for coming in. We'll be starting our webinar in the next 3 minutes.
I think I jumped the gun on that.
Go. Perfect.
All right. So you can see.
I can see this, that, and even the rest people can see that need.
Can see everything on my screen, or just the
everything.
slideshow.
Everything, like the slideshow on the side. So.
But you can't see like.
No, nothing else. Nothing else.
The other windows. Yeah.
No,
that's actually okay.
That's beautiful.
Yeah, that's actually okay. I can. Yeah, that's actually going to be fine. I think I'm actually going to present like that. Like it's small.
Beautiful. Perfect. So like next 1 minute we can start.
Okay, great. And it's sufficiently large that people can see it, or is it just like 1/4 of the screen?
If you go on a slideshow, and so it's much better. So it'll be a full screen.
I was hoping not to, because I have 2 screens and it winds up kind of messing things up here. Let's see. Yeah, that's less than ideal, but we can.
No, it's perfect. It's perfect.
It's perfect. Okay.
It's perfect.
So you can't see the slides on the bottom. You can only see.
I can only see the main page. I can only see
just the main page of the slides.
Right. It's beautiful. It's beautiful.
Perfect. Okay, cool.
So in a minute. Okay, so we start now. Thank you all the attendees for taking time to join today's webinar. Our topic is preventing impact noise in residential construction. We are excited to welcome Michael Ermann, a recognized expert in acoustic design and noise control. I would let Michael do his introduction. He can do it in a better fashion, so I'm going to go off camp and he can be talking. Michael, back to you.
Hey, everybody. So impact noise is generally caused by, well, at first approximation, it's caused by footfall. Of course, it can be caused by any impulsive impact sound. So it could be a cabinet slamming or exercise activities like weightlifting, weights dropping, could be furniture moving or pots dropping. But generally, when we're talking about impact noise, we're talking about footfall. And if you've ever lived in a place with someone walking above you, especially if you lived in stick construction, wood construction homes, like the multifamily homes, although it certainly could be a hotel or a dorm or something like that, it's quite a good likelihood if you've lived in one of those situations where you can hear the people upstairs. And because impact noise is it's really insidious. It's like really insidious, because it's probably the most difficult thing to address in acoustics, certainly the most difficult of the common things to address in architectural acoustics, because, well, a couple of reasons. One is it doesn't have to be loud to annoy people. Many reasonably minded people are annoyed just by the audibility of someone upstairs. Now, how much they're annoyed may depend as much on who's upstairs as how much noise is actually measured. So in other words, if it's your own kids or dog walking around upstairs, most people feel a little bit differently than if it's someone else's dog or kids upstairs. And just by coincidence this month, I asked the internet where the term "waiting for the other shoe to drop" came from, having no idea that it had anything to do with impact noise. just kind of out of curiosity because my wife said that phrase. And it turns out it originated from about 100 years ago in the tenements of New York City, which were built pretty not that well. And when the person came home from work, they would take off one shoe, and then you would wait for them to take off the other shoe, or wait for the other shoe to drop. So it's actually an American expression, and it's much more recent than I would have thought. I kind of expected it to be from Shakespeare or some ancient proverb. But so the mere audibility of the noise from upstairs may be enough to make reasonably minded people dissatisfied. So that's one problem. The second problem is that it's super hard to fix after the fact, unlike most acoustic issues, which typically have sometimes an expensive or disruptive solution. The solution for this kind of thing, if you can hear the people upstairs and it's driving you crazy, the solution is to move everyone out and rip everything up and redo a bunch. And that's really difficult because sometimes now the ceilings aren't high enough to meet code because you've made this floor ceiling assemblies thicker, and it's created a whole bunch of dust. And it's very common to have lawsuits in this kind of space. It's super common to have lawsuits in this space. And in fact, a lot of what's acceptable or unacceptable in impact noise is not being determined by the codes or by building science. It's being determined by the lawyers and the lawsuits, because it's condos. If you've ever heard that condos or know from your own experience that condos are where the lawsuits are, what happens, of course, is people are very sensitive about their homes. And of course, impact noise is really an issue when people are trying to sleep and people are walking above them. And condo fees are quite high, and that money's going to something, and it often goes to lawyers. There's often a lawyer on the board of a condo. And when the condo isn't happy, when the condo occupants aren't happy, or some of them aren't happy, or the loudest ones aren't happy, they have a really easy kind of, with the condo board, they have a really easy kind of ready-made institution to file a lawsuit and see if they can get it fixed. And the third reason, so the first reason is that, it's mere audibility that could drive someone crazy. And the second reason is that condo boards sue because, especially now that, a few things have happened. One is we're building out of stick construction, and as we're going to see, light wood construction is really problematic when it comes to impact noise. Number two, people just don't use carpet as much as they used to. We're going to see that carpet is actually really effective at reducing impact noise, and people don't like carpet because, well, carpet sucks for all kinds of reasons. And number three, it used to be poor people lived in cities and multifamily housing, and they didn't have the wherewithal to file lawsuits as readily as the rich people, often rich people who have lived in the suburbs with their kids and are now retiring and move to the city and expect city life and action, but really don't expect the kind of noise associated from someone walking above. And so, so because people go nuts, and because mere audibility can drive someone crazy, often what happens is, after the fact, if you try to fix it, reasonably minded people hear all the people walking above, and it drives them crazy. And then you fix it, and I say fix it kind of in air quotes, because you can't make all the noise go away from someone walking around, especially a dog or a kid, smashing down toys, without carpet anyway. And so after they've moved out and they've been disrupted and it's caused all this pain and money, and they move back in, they expect it to be fixed. But it's not fixed, it's just quiet, and it's often quieter, and it's often quiet enough that if it had been like this the first time, they wouldn't have had a problem with it. But now that they've gone through all this and they can still hear it, they don't remember exactly how loud it sounded before. Maybe it sounds a little quieter to them, but that's like, well, you didn't fix it at all. So it's those three things, a combination of mere audibility being a problem for some people, and condos being a vehicle for lawsuits, and the kind of the combination of those two, where afterward people kind of expect it to be fixed, and it's never really fixed. Again, especially in wood construction. So what you're looking at is you're actually looking at concrete construction, and the number down the middle is called IIC, an IIC is a flawed, but a measure of how effective a floor ceiling assembly is at transmitting vibrational impacts from footfall noise down below. So, and actually, I'm going to introduce myself. If we could turn on the camera back to me, or I could just stop sharing, I guess, when I do that. Did I stop sharing?
Yeah, it's absolutely
it's
fine.
back
You
to me.
stop sharing.
Yeah, let's see if I actually, I should probably introduce myself. So I'm Michael Ermann. I'm an architect, and I'm an architecture professor at Virginia Tech. I also started the course Amber Book. And Amber Book, some of you guys know what it is. We have about 30,000 paid enrollees now. We're to the stage now where I think most people who are seeking licensure are using Amber Book to study. I put maybe, I don't know, 2%, 1% of the content of Amber Book on YouTube, and that channel has 9 million views and 40,000 subscribers. Anyhow, that's me. I teach studio. I teach building assemblies like this, and I teach details. I teach building assemblies, and I primarily teach. Well, I primarily teach studio these days, but historically, I've often taught building systems. So everything from acoustics and lighting to thermal performance, energy performance, and HVAC. That's kind of some of the things that I really enjoy digging into. And most of the images all the images just about you're going to see on this are actually from my book called Architectural Acoustics Illustrated, which was published by Wiley. So anyhow, let's take a look. Let's see if I can do this. There's only, I love props, but I don't do too many props on webinars, but let's see if I can do a prop, because the way that we test the impact insulation class, and remember, a higher number is better, is more robust, a lower number is less robust. And for reference, kind of, if you did nothing, if you just kind of had a bare floor, your IIC might be something, in concrete or wood, might be something approaching 30, an IIC 30. So you did nothing, you just have a bare floor, like subfloor, and people are walking around above. You have no ceiling, you're just kind of looking up at the joists, and you would have an IIC of about 30. And most reasonably minded people would find that objectionable. If we did a bunch of things, all the things that we're kind of looking at here, or we were looking at in the graphic that was up before, if we have floating floors and suspended ceilings and all the fixings, we might achieve an IIC of 70, which is really good. And most reasonably minded people would not be dissatisfied with that. They would not be annoyed, or at least not highly annoyed. Although certainly some would. That's one of the many problems with this with this particular field. Go ahead and put on the chat if you can, if there is a chat. Go ahead and put on the chat what the code minimum is in the US.
So the section, the Q&A, you can put it on that to all attendees.
Okay, you can put it on the Q&A. Yeah, I mean, code minimum is 50. And it's kind of weird with 50 because 50 reasonably minded people, some of them would find IIC 50 acceptable and not be highly annoyed, and some reasonably minded people would find 50 to be really annoying. And this is why the lawsuits and not the code are one of the reasons are really determining how this stuff works, because the code minimum is not great. So this is one of the many places in the code, but one of the most important in the code for multifamily, where you really don't want to shoot for code minimum. You want at least, I would say, IIC 60 in most cases, and maybe even 65. But anyhow, the way we measure IIC is we have what's called a tapping machine. And the tapping machine, if we kind of take it apart, the tapping machine I have behind me looks like this. Oh, you don't have, let me share again. So that looks like this. Hopefully you can see that. And down in the lower left-hand corner is a tapping machine. So if I zoom in, it looks like this. And there are these little pistons that drop from, I think it's an inch high, and there's metal pistons, and they free fall drop twice a second, and there are 5 pistons. So 10 times per second, you hear tap, 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 tap. And what we're going to do is we're going to turn that machine on. I'll go ahead and turn it on now. Let me go ahead and stop sharing so you can see what it looks like. I have it on the floor, so we'll see if I can kind of show it to you. Believe it or not, I'm in my office, but my office looks like a house, and my house looks like an office, so that's weird. Let's see if I can bring it over. It's in screen. Here it is. And I'm going to turn it on. It's going to get really loud. So put in the Q&A if you heard that. I assume you did. So my microphones are all set up correctly. So what you just heard is that tapping machine. And what we're going to do to measure the IIC is we're going to run the tapping machine in the apartment upstairs, and then we're going to take microphones in the apartment downstairs, and we're going to essentially take a measurement of how loud it is at different frequencies. We're going to do a bunch of things to put in post-processing that are not very complex, but are kind of complicated and certainly not worth exploring now. But we're going to come up with a single number. And like so oftentimes happens in acoustics, a single number is very useful in comparing, in this case, different floor ceiling assemblies, or seeing if we've achieved some kind of a minimum performance. It's very useful, but it's not particularly accurate. And so IIC, and here it is for wood construction. And here are the IIC values for wood construction. IIC is going to be a single number measurement that's kind of crappy. Like if IIC was a person, you would not like them very much. So again, just you guys let me know if you can't see. I understand this is not perfect for the screen, but just let me know if you can't see anything. So IIC is the best we have. It's widely accepted. It's widely accepted. Now it doesn't work for several reasons, and it's not great for several reasons. It works. It works. We've managed to live with it for 75 years, but it's not great for several reasons. The first and most important reason is it really doesn't do well for wood construction, in part because when it was created, we really weren't making a lot of multifamily housing out of light wood stick construction. And so it was kind of made for more dealing with the clack clack of high heels from the 50s walking around on a concrete floor than it was for kind of, heavier, we're heavier now, so heavy person walking around on a deflecting wood floor. And so wood in particular, because of the deflection issue, because of the stiffness issue, it's usually not stiff enough to perform super well under the weight of a person. So that click, clack, 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 clacking, and the way that we post-process it especially really doesn't account for the wood. So it's actually quite possible to have a pretty robust IIC rating in a stick constructed building and reasonable people to be really, really annoyed by the people walking above, even though the IIC is a high number. It's also worth noting that IIC has nothing to do with sound transmission, airborne sound transmission. It's only about structure-borne sound from that, from the hammers hitting the floor. And likewise, it has nothing to do with sound absorption, the kind of thing that you would find in an acoustical ceiling tile or wall panels. And that's more about the people in the room being able to hear the person who's speaking or playing music in the room. So NRC is our single number measurement for things like recording studios and opera houses, so that the people inside the room can hear, or theaters or lecture halls. So the people inside the room can properly hear the other people inside the room. Completely independent of that, completely orthogonal to that, but completely separate from that. In the same way that you can have a car that is both fast or slow on the one hand, or brown or yellow on the other. So completely different. We have sound transmission class. That's our single number rating for how effective a barrier is, like a wall or a floor ceiling assembly, in keeping out the airborne noise, like from a TV in the apartment next door or above us or below us. And completely separate from that, in the same way that a car can be fast or slow, or can be brown or yellow, or it can be big or small, we have IIC. And so in the same way that knowing the IIC really doesn't tell us anything, I mean, the same way that knowing the car is brown doesn't tell us whether it's fast or slow or big or small, knowing the IIC does not tell us really anything about whether the assembly is going to be good at keeping an argument out from the people next door, or the stereo out from the people above you, or I don't know, fireworks out from the people outside. That's completely different. So what we're talking about here is the IIC. And to achieve a good IIC, really there are probably two things you should focus on. Let's see if I can draw it. I have an iPad to draw it on, but my iPad, we can't connect to the system. So I'm going to go ahead and I'm going to see if I can draw it here. So if this is with a mouse, so forgive the drawing. So if this is a section through our floor ceiling assembly, what we're going to do, and let's say this is wood construction. So what we're going to do is we're going to have a floor, whether that's vinyl or, well, if it's carpet, then we're pretty much set. Like carpet, if you have carpet, you're pretty much set. It's very, or cork or rubber. The best way, by far the best way to address this issue is just put carpet on the thing, and you're fine, because you're dampening the impact noise before it's even made. The problem with carpet, besides the fact that carpet sucks, is that someone may rip out the carpet eventually. So even if you put carpet in now, later on that may wind up being tile or hardwood floor or vinyl. And so I think we probably ought to plan for it not being carpet one day, even if it is. But carpet's the way to go if you only cared about impact noise and didn't care about, I don't know, allergies or dirt or off-gassing or aesthetics. But anyhow, you'll have we're looking at a joist, and then above the joist, we'll have a subfloor, which looks like this. And if we want to have a more robust assembly, what we're going to do is above the subfloor, we're going to put a resilient mat of some kind. Could be a pad or a mat. And I have some samples I'll show you. Told you I love props. So this is our mat that we're going to put down. And it's kind of like a wrestling mat. You can kind of think of it like a wrestling mat. And so I'll show you some examples. All right, so the mat itself looks something like this. This is a fairly thin one right here, and it's kind of like a rubberized one. This is a thicker version of the same thing. I don't know if you can see it's thicker, but it's thicker. And this is a still thicker version. This is a pretty robust one with kind of an egg crate on the bottom version, and it's squishy. So let's see if you can see. It's rubbery. All these are rubbery. Now, architects and owners love the thin ones. Some of them are really thin, like paper thin. And they love the thin ones for several reasons. One is they don't want the extra floor ceiling assembly thickness, so they can have more ceiling height or more floors. But the main reason is because it's really difficult with the thick ones to figure out the doors, because the doors kind of come in preset sizes. So So if you start putting all this padding down, suddenly the doors don't work anymore. The doors that you buy, that kind of pre-assembled, don't work anymore because they're not made for that thickness of floor. Same with cabinets. So people like the thin ones. The problem is the thin ones really aren't effective. And these things are, the thicker ones are generally pretty effective. So thicker is better. Generally, most of the ones that are thicker than 1/4 of an inch perform much better than those that are thinner than 1/4 of an inch. So thicker is better, just from an acoustical point of view. This is one that's kind of, it's like almost like a filament. And you can kind of see it's squishy. So almost picture the gauge of the filament that's in twist ties, but it's all kind of matted together and made into a hairball. And then that's made into a mass. So this is another proprietary one. There are lots of them. Some are kind of almost cardboard based, that are kind of squishy, but it's just kind of, the idea is a squishy thing. Anyhow, so we're going to put that on top of the subfloor, at least in the example I'm showing you. All right, so we're going to put that on top of the subfloor. That's our blue. The subfloor was green. And then on top of the mat, we're gonna pour I don't know, usually a couple of inches of a gypsum concrete topping, which is just what it sounds like. It's a cementitious, wet, nasty thing we're going to put on. And it's really problematic to put it on from the point of view of, well, it's heavy, so we're going to have to size the structure bigger than we would have otherwise. And it's wet, so we're going to pour all this, wet concrete on this wood structure and, hope that things don't warp. It's expensive because gypsum concrete's expensive, and it's expensive because it delays everything. You have to wait for it to cure. So it's a total mess, but you really need it, or do you? We'll get to that in a second. You really do need it to make the whole thing work, because without it, you get that. And it used to be really hard as an acoustical consultant. It used to be really hard to convince people to put it on, but enough people have been sued enough times that any owner with any experience, they know it's coming. They know it has to be on. Or does it? We'll talk about that in a little bit. But by putting it on, you're adding, in this case, mass. Now we can put it under, if we don't, we'll talk about that in a second. But we're putting it on top of, we're adding mass, and that's going to allow the system to potentially be quieter, certainly. I shouldn't say quiet, because like I said, you never know. So anyhow, on top of that, we'll put our finished floor. And you notice that I really didn't touch the wall, and that was on purpose, because as my foot pounds on this surface, we want the concrete slab, essentially. It's not slab, but the gypsum concrete pour. We want that element to kind of squish on the thing below it, but we don't want it to transmit energy to the wall that would then go through the wall and they come out the other side down below. It's called flanking path. It's essentially a short circuit. So what we're going to do is we're going to take the manufacturer typically the manufacturer of the underlayment, that kind of squishy pad, is going to also provide, or you're going to be able to buy what's called an perimeter board. And it's essentially a squishy board that goes in here. And that squishiness isolates the footfall from the structure. And then likewise, we're going to put our molding here, and we're going to attach it to the wall, not the floor. And we're going to use caulk everywhere, right? So there'll be just all this caulk in places, and we're talking about non-hardening caulk, so that we're essentially isolating floating the floor above the structure, and then underneath the structure, we're going to take, in this case, the joists are going right to left, so perpendicular to that, we're going to take what's called resilient channel, which is a floppy metal thing that that runs between the joists. And what we're going to do is we're going to support the gypsum board, or better yet, 2 layers of gypsum board on that metal channel, and that's called the resilient channel, or resilient clips, or spring hangers. And that's essentially going to make the ceiling also springy. So that's the name of the game, is to make a discontinuous assembly in wood construction, and to some extent in concrete too, to make a discontinuous assembly so that the impacts created above have 1, or better yet, 2 breaks from the structure below, where it's less likely to radiate. So let me again show you some props so you kind of see what it actually looks like. All right. So let's see. The resilient channel, the resilient channel that I described, it's kind of weird. You guys can tell me on the Q&A whether you found this stuff. There used to be a bunch of manufacturers of it. There weren't many last I checked, so I'm not sure if it's something made. But it's pretty effective and pretty cheap, and it's basically just a floppy piece of metal. And that floppy piece of metal is going to go between the studs. Let's see if I think I have it in the drawing. It is on a wall, but it's going to go between the studs like this, and perpendicular to the studs. In our case, we're talking about the joist, because what you're looking at is a wall, but we're talking about a floor ceiling assembly. Oh no, you can't see that. Hold on, let me show you. Yeah. So so you have the resilient channel, and in this case, going from stud to stud. In our example, for a floor ceiling assembly, it's going from joist to joist, but it looks like this. And in real life, non-drawing world, it looks like this, and that's going to go across. Now, there's another option, which is called a resilient clip, and this is one. And so you see, you'd have the joist, and then you have this kind of rubberized element, and that isolates the joist from, and actually you'd probably turn it like this, right? No, you'd have it like this. And then the hat channel, you put hat channel, it just clips in. It's pretty effective. I mean, it'll add maybe 5, 6, 7. All these techniques add 5, 6, 7 or more IIC to it, but it varies significantly from assembly to assembly. And so then you can suspend the drywall. You can attach the drywall to this. So you're attaching the floppy thing to the stud, and then you're attaching the gypsum board to the floppy thing. And so that's what this looks like. It's not to be confused with normal hat channel. Normal hat channel really doesn't work because it's just not floppy. It's too rigid. So if you have normal hat channel, which contractors love to use because they use it all the time, and it's less expensive than those proprietary clips, they'll say, oh, we can just use this, but it's too rigid, especially when it's pinched in. It's too rigid, and so it doesn't act as a structural discontinuity in the same way that it would for resilient channel. Which again, the resilient channel, we're going to attach part of it to the joist, and we're going to where this hand is. Sorry, this hand is going to attach to the joist, and this hand is going to attach to the drywall. You're just going to screw into it with screws that are not too long, because if you screw long screws in, it'll go right through to the joist, pull up behind it anyway, and short circuit the whole effort to separate them. This is another proprietary one. Again, the hat channel goes into this rubbery thing that is discontinuous structurally. And here's another one. It's like this, a little bit smaller profile. Anyhow, that's our idea. Or we can attach it with frame hangers, so to kind of bring out the big boys. And we can use something like this, and then the weight of the gypsum board kind of sits on that. So anyhow, this is that's the world of suspending the ceiling.
So, Michael, there's one question by Fiona Matthew. So she asked, "Hey, Michael, thanks leading this discussion. You may cover this later, but what would you say to the client who do not want to include optional acoustical mat between to create an RUL design? Are these tests out there with LVT finish floors that meet the minimum code requirement for IIC and STC?" It's in the Q&A there, so you can read it yourself. So, inside.
So the question is, are there tests out there that meet the requirement without the underlayment?
Right. So are tests out there with everyday finished floors that meet the minimum code requirement for IIC and STC?
The short answer is no. The long answer is maybe. So what winds up happening with the IIC, besides its shortcomings in wood construction, it has some other problems. One problem is that it doesn't take into account the way it's tested in the lab. They just take a little sample, like I think a 4 foot by 4 foot sample. So deflection is not really an issue. Stiffness is not really an issue. So they'll take they'll frankly build the test sample with like way more joists than there normally would be, so that it outperforms what it will in real life, because it's not kind of deflecting. And so and then also it varies. IIC varies wildly. So you can find published data that are amazing that turn out to not be at all representative of what you get on your building. And you can build your whole building the same way, and from one apartment to the other, it can vary by 10 points or more, up or down. So it could be like almost 20 points from one room to another, one room to another. It's crazy. It is crazy how inconsistent it is. And then, of course, because of that inconsistency, the manufacturers take advantage of that, and they publish only the best score they've ever received, the best score they've ever earned in a lab for a lab test, and there's also field tests. So the lab test requirement for IIC in the code is 50. For the field test, it's 45. I think it's about to get more complicated, and you guys can tell me if it has in your particular state, if your state's adapted the most recent codes, where there's actually not just an IIC, but what's called an HIIC and an LIIC, so high frequency and low frequency. It's a better measure of how the assembly does in the low thuddy sound of wood. But anyhow, the short answer is, if you have, there may be some unscrupulous products out there that can get you to the minimum lab tested IIC of 50 without a thick underlayment. But it's unlikely that it's going to perform that way when you actually install it. So when the lawsuit comes and the lawyers hire an acoustical consultant and they take a measurement, it's going to achieve, I don't know, 38 or 39 or something like that. And they're going to say, you said it was 50, but it was only 39. And part of the problem is that it's kind of like I have a slinky in my hand here. So it's kind of like a spring. So the top one is a spring, the kind of the underlayment is a spring, and the resilient channel, resilient clip, or spring hanger that's going to support the gypsum board is a spring. And if you take a spring and you attach it to, I don't have a second one of these, but if I attach it to another spring with two different weights on there and some weird things start happening when you start exciting it, moving it up and down. Oftentimes they cancel each other out, but sometimes they amplify each other. You kind of get a double bounce like you see kids do on a trampoline, if you can time it kind of just right. And so sometimes that's really what acoustic waves are. They're just kind of timed bounces, and especially structural ones like this are similar. So not every combination of every thickness of vinyl and every thickness of gypsum concrete and every proprietary manufacturer of underlayment and every type of resilient channel that's holding every different type of gypsum board, and some gypsum boards that far outperform others, surprisingly, and have been tested. So even if you find one that's quote unquote works, it doesn't really mean that your particular combination is going to work. It just means that some combination using probably some underlayment and some resilient channel that was somewhat similar to yours. Usually the underlayment are the people who make the underlayment are the ones who do the tests. And so it depends what channel they used or what clip they used, and it depends what gypsum board they used, and it depends what the thickness of their subfloor is. And so usually the code official will say, well, if the test says that with an underlayment and with 5mm luxury vinyl tile and with 5/8 inch gypsum board below, or with gypsum board below, it usually the code officials are fine with any thickness. They'll often take the test at its word, and so you'll meet code. But like I said, it seems to be in this world when you have experienced owners, especially if it's kind of high-end construction, they understand lately, the last 15 years, 10 years, they seem to understand that this stuff is important. But if you can't convince them, I don't know. I guess you just find something that cheats it and meets the code minimum, but cover your butt. Write lots of text to the owner saying, I think that reasonably minded people, even if it meets code, may be very dissatisfied with this. So yeah, I don't know how to. I'm not good at convincing people. It's not my specialty. I've never been very good at it, so I'm not really sure on the person. All right, so back to our drawing. Now, likewise, if we have ducts or pipes or something like that, that's going to penetrate through the floor, we're going to again want to take the squishy stuff, the perimeter board, and we're going to want to put it here, or some kind of squishy material, and lots of caulk around the top and so forth, so that same with down here, a little caulk here, so that the pipe can penetrate through. And again, we're less likely to have flanking paths where it's going to go through the pipe or through the duct. So basically, it's there's not really a detail that I can give you that will explain everything. You just kind of have to be smart about it and say, okay, where is the footfall, and does that touching anything that's connecting the floor above with the floor below? And if it's not, you've addressed flanking paths. And if it is, if you put like I mentioned, if you put a really long nail in there, well, that's a flanking path. It's short-circuiting the efforts we've made to separate these. So, all right. So we're going to excite it with impacts, and we're going to come up with an IIC number. And remember, I said that we really can't do it without concrete. And it's funny, in preparation for this talk, I went and read my chapter on this topic in my book. And I said in the chapter that basically everyone I basically said anyone who's not an idiot who knows about this stuff knows that if you have wood construction and you want to achieve something good, you need to pour concrete or some kind of cementitious product down. But since then, I've kind of gotten to thinking, and I've started a company. I'm getting you the link. Hold on. I started a company because we think that if we have total control over the floor ceiling assembly, in other words, remember I said it's very unpredictable because you might not be using exactly the right gypsum board or thickness of subfloor or resilient, the exact combination of this particular type of underlayment and this particular type of spring hanger for the ceiling in this particular thickness of vinyl and so forth. So there's often not, it's just too open-ended. And so in the same way that Apple Computer is kind of made its name that things just work better, but you don't have much flexibility if you're a programmer, you're a coder, and the coders don't work on Macs, but many of the rest of us do. In that same way, is there a way I can put in the chat where people can see something?
Yes, you can put it in the Q&A section.
Okay, I just put it in what I think is the chat. And so hopefully people can see what I just put in there. I have a manufacturer who's actually pretty interested in making this. So basically, we would control, and I say we have a partner in this who's an expert in this as well, and we would control basically you would, instead of the contractor ordering this much underlayment and this much plywood for OSB for the floor assembly and this many spring hangers and so forth, it would instead say, okay, we have this many square feet of floor ceiling assembly, and so we have 45,000 square feet of floor ceiling assembly. And then it would essentially all come together. In other words, it would maybe not at the same moment, but we meaning the product would have total control of everything from the ceiling up through the subfloor up top. Maybe not the finished floor. People like to have control over that, but the subfloor from the top down to the gypsum board on the bottom would all be kind of one package essentially, and would be delivered to the construction site when needed. All kind of the number that we say, the number of spring hangers that we say you need. That's the other thing. Contractors love to cheat you on spring hangers because they're expensive, and it all gets sealed up, and you don't know what's in there. So if we, kind of would send enough spring hangers to work and the right fasteners to make sure that there's not as much flanking, and enough perimeter board and videos to show how the whole thing works. Anyhow, I'm pretty sure, and so is my colleague, John, who does 500 of these, he tests 500 buildings a year. And think about that for a second, in impact noise. And we are pretty sure that if we have total control over everything, we can get a robust, high-performing floor ceiling assembly that most reasonably that more than meets code, and most reasonably minded people would, we're thinking ISC maybe 60 or 65, even with a hard surface on the top. Most reasonably minded people would find that to be acceptable, and it wouldn't need concrete, most importantly. So you wouldn't have the delays and the moisture and the weight and the cost. So if you think you or your clients might be interested in that, it's just a short, all I ask for, I think, is your email. And that way, if we get something going, we can send it to you and you can say, no, that would never work. And you can help us make it work. You can help us, you can basically become our partners and help us make it better. Anyhow, so why don't we open up the questions for a few minutes? And if we don't have many questions, I'll keep going, but I want to make sure I can answer questions you guys may have.
Fiona also did ask about Jitpreet. So she basically asked,
hold on. I'm putting the link in the Q&A. So now it should be there. I was told. Oh, someone else did that. All right. Sorry. Go ahead. Go ahead, Ian.
So our first question was, for the clients who do not want to include optional acoustical mat below the Jitpreet in our UL design. Someone want to?
Yeah. So no, I don't think you want optional. I mean, you need to, the assembly you have needs to meet code, right? So it has to, if you can find an assembly that has an optional underlayment that still meets code without the underlayment, it's probably doable, especially if you have pretty robust spring hangers on the bottom and have something pretty squishy at the top, like not tile. You may be able to get that kind of thing. Some hardwood, engineered hardwood, and other products might have a little bit of felty stuff underneath them. That helps a little bit. I didn't put it in the drawing because I forgot to, but putting a little bit of acoustic insulation, which is essentially bad insulation just without the craft paper facing. Putting that in the cavity helps, but not as much as you'd think as in wood construction. In concrete construction, it does help a little bit more. I should add that acoustical ceiling tile does nothing. You might as well not even have it. So gypsum board is helpful, but acoustical ceiling tile is not, which again surprises people. But acoustical ceiling tile is all about sound absorption and NRC and kind of hearing the people in the conference room. If you're speaking in the conference room, having the other people hear you clearly. Acoustical ceiling tile is really actually pretty crappy at preventing the clack, clack, clack from above to penetrate through. It does almost nothing. Yeah, I mean, I don't know what I'd say except for that to perform well and to provide occupant satisfaction, you pretty much need an underlayment in wood construction. Now, there are other ways to deal with this. And these really are quite the purview of the architect. So don't put a kitchen above a bedroom. People won't like that when there's clacking on the kitchen floor. If you can, maybe don't stack, maybe you can do a townhouse party where there's one building next to each other instead of one on top of another. So there are things you can do in early design before everything's kind of set, where you can start to address some of these things, and we can go over them in a minute if we have time. I have a checklist for you, but there's no way to know for sure exactly how it's going to perform, but you can get fairly close with the ISE. All right, let's see. Thanks for the discussion. Okay, someone already asked that. Okay, let's go back to the slideshow here, and we'll wrap up with a checklist for you. And you guys can whip out your phones, and you can take photos of the checklist. So in early design, I mentioned partie, so let me share here screen. I mentioned the partie, the idea that that there are ways to organize your building so there's not a weightlifting gym above an apartment, for instance. So partie and program, those are the first two. Generally people, I don't want to say always, but generally there are not as many complaints that people have in the workplace, in part because it's more likely to be not wood construction in the workplace if there are people above them for all kinds of fire code and structural reasons. But in part because people just during the day don't mind it as much, I think, when there's noise. There's a lot of noise also that might drown it out from other people talking or the water cooler cooling or whatever. The concrete, we really didn't cover concrete too much, but in concrete construction, underlayments are also important. But as I mentioned, having a ceiling underneath the concrete, not having exposed concrete from below, is actually quite helpful. And being able to have at least 4 inches, better yet 8 inches of kind of airspace between the floor of the concrete and the top of the gypsum board that's being hung below, and taking that insulation and putting it in that space. That's how you deal with concrete. And concrete, like I said, you're far less likely to have complaints, although you certainly do have some if you have just bare concrete with nothing above it and nothing below it. And the International Building Code, the IBC minimum does not equal satisfaction. So kind of educating your clients that code minimum is not really enough in this particular domain. For assembly performance, less deflection is better. Generally, you want to have about a quarter of the deflection that typically structural engineers feel comfortable with. So that means you have obviously deeper joists and or shorter spans and or closer spacing between the joists or wood trusses. IIC, which is impact noise performance, has nothing to do with STC, which has nothing to do with NRC, which is absorption in the room. So just because something is, there's lots of examples of assemblies that are great at STC that keep the TV from one apartment out of the other, but really, really bad at IIC and vice versa. Carpet is amazing. Underlayment is amazing. Resilient ceilings are pretty good. I mentioned airspace in the concrete with BAS, with that insulation, and is worthwhile. And also for concrete, well, sometimes for something really robust, if we really want to do it right, we will have a floating floor. And so what we'll do is we'll have our structural concrete floor, and then we'll put down springs, we'll space out springs, or we'll put down a proprietary element like this that has squishy kind of neoprene pucks. And that'll sit there, and then we'll pour a second concrete floor, topping floor on top of that. I'm not typically talking about gypsum concrete like an inch or two. I'm talking about, another 4-inch slab. So it's super thick. It's kind of like a bomb shelter. This is another proprietary thing that kind of sits on and then you pour the concrete on top of that. So there are floating floors for concrete as well that we haven't touched on, but you get the idea. It's actually pretty much the same, except for instead of an underlayment, it's just instead of an underlayment with a thin gypsum topping on top of it, it's a bunch of springs or neoprene pucks and a second structural or non-structural floor that again is not going to touch the sides, not going to touch the walls, but it's going to come pretty close to touching the walls. All right. And wrapping up. For flanking, that's this idea of short circuiting. We have to put perimeter board around the floor edge. Anytime we put anything in the ceiling, we're creating a flanking path. So if we have recessed lights, that's a flanking path. I suspect, frankly, that the reason that hotels almost never have lights above is because they don't want that flanking path of the people walking above. I think that's why hotels often have carpet. Even in a hotel you wouldn't think would have carpet based on how fancy it is, because they're dealing with the impact noise issue. And I said vents there. I know you should never call them vents. They're registers if they blow air out, diffusers if they blow air out in a direction, and grills if they suck air in. But I just put vents there for you to remember in case you're taking a photo. So anything that's in the ceiling is going to be a pretty significant flanking path, and you want to avoid it. And it's kind of like, it's not quite like it only performs as well as its weakest link, but it's kind of close to that sometimes. And then I didn't draw this, but the wall on the floor, let me go back and just draw it actually. For reasons that will become obvious.
Meanwhile, if the attendees have any questions, feel free to drop your questions in the chat box. We'll try and take them now before we wrap up.
Yeah. So here's your ceiling. You can see your ceiling, your gypsum board ceiling, and you have your wall board on the wall, and you want the wall board to go past the ceiling board. And the reason is because if it does not go past, then the ceiling board will rest on the wall board and it will be a flanking path. So we're going to take caulk, which I think we did in green. And we're going to, again, take a non-hardening caulk, acoustic caulk, and we're going to put it here. And we're going to allow the wall board to win as it goes past the ceiling so that the ceiling does not rest on the top of the wall board. So that's our last of the flanking path. So thank you guys so much. Let's see if you have any other questions before we wrap up.
Thank you so much, Mike, for sharing such valuable insight. That was truly informative. Any question and answer session? We are open for discussion.
Someone asked, in a floor ceiling assembly, could the use of thick cushion materials for noise reduction lead to leveling issues over time due to material compression or settling? That is a great question. Whoever asked that, I think that's Rajat. You're really, really smart. That's something that I don't understand either. I mean, basically, these materials have been tested over time. If I was making new material, which I kind of am, That's something I'm really frightened of. So we're going to be using existing long proven materials. It's kind of the assembly of them, of the kind of control of them and the vetting of them that we're offering, but in our proposal. Yes, and that's why actually at one point I had thought about you, because these underlayments are super expensive. And I had thought about using carpet pad, because certainly carpet pad's been around a long time, and we know its fire code limitations and achievements, and so I was thinking about doing carpet pad as but that was part of the issue, is that over time it's just not level enough. Now, what happens if there's no concrete? If there's an underlayment but no concrete topping, we have the subfloor, then we have the underlayment, and then we have basically a second subfloor. So we have two more. If we don't have the concrete topping on top, we have usually two more layers of OSB. So we essentially have a wood floating floor on top of the underlayment. And so the compression isn't really an issue, because I think whatever's on top of the floating floor, or the underlayment rather, generally whatever's on top of that, the weight of that, the force of that is distributed out and kind of evenly across the floor. And so we're hoping not to have that kind of thing. But I have not heard of examples of problems with that, or with unevenness in the floor, because we're not putting like the tile right on top of the wrestling mat. There's always something on top of the wrestling mat that's rigid. All right. Any other questions before we?
Any
All right.
questions?
All right.
So we
I
wrap
wish
up.
you guys. Yeah, I wish you guys all a very quiet sleep tonight, with no one walking above.
Right. So thank you, Michael. Thank you all for joining us today. We hope you found this session insightful and valuable for your projects. A big thank you again to Michael for sharing insights with us. Have a great day. We look forward to seeing you in the next webinar. God bless. And
Bye, everybody.
take care. Thank you, Michael. Bye.